So welcome back to Space-Time and Artificial Intelligence, the ARC 509 course for fall 2020, which pertains to the interrogation of automation, artificial intelligence, and post-human design agency. Last week we started with a lecture on art and artificial intelligence, and I wanted to expand this to a couple of other areas, as it would have been difficult to combine all of these into one large lecture, so it's broken up into several. And one of the areas I would like to discuss today is music and artificial intelligence. Music in the eyes, as you remember that last week when we talked in general about art in the eye, I had this example of photography being a technology that profoundly changed the course of art history through its invention. And of course, there's many of these sort of inventions in the music area, but we will see how basically AI is changing music. And also, I would like to add that this is, of course, not the first technology to change music, but also it needs to be said that there is a specific idea of, or desire, let me say, of humans wanting to use machines to generate music automatically. So let's talk a little bit about the origin of automated musical composition. Automata do by far most of the part not create automated music, but it seems the desire to have a machine that creates music is an old one. And you might remember from last week that we applied a variety of different criteria to the creation of the arts, and more specifically intent, intuition, and authorship. And a concept that I lifted from Aaron Hertzmann's lectures, and that I would also like to apply to my lectures here for the course. Music in general is a powerful combination of material and symbolic culture, as it combines aspects of cultural exchange, ritual, and pleasure with the necessary material artifacts to express music in physical sound waves, from wooden claves to the piano to digital sequencers. Since the invention of musical annotation systems, it includes a data compression method to record and preserve the artistic intention. And I would like also to point here to Mario Karpo's book, The Second Digital Turn, where he discusses aspects of data compression and the transformation that is currently happening when it changes from data scarcity, where data compression methods were really very necessary and useful, to big data, which of course allows you to use data in a completely different way. You might remember, again, also from last week, that we applied these different terms that we're using here to define the criteria and aspects of the work we're seeing. A little bit about automata. Yeah. So in our conversation, the term machine, yeah, because we're talking about a little bit about the origin of music machines, yeah. In our conversation, the term machine can be expanded from mechanical devices to software. But a little bit about automations and automatons and their role in the lineage of music-making machines. In general, automatons are designed to arouse interest through their visual appeal, and then to inspire surprise and awe through the apparent magic of their seemingly spontaneous movement. The majority of automatons are direct representations of creatures and plants or kinetic aspects of natural phenomena. Imitations of such natural phenomena as the moving water of streams and waterfalls, for instance, can be simulated with crystal shreds of glass. A mechanical device can be used to make a flower open its petals, to imitate blooming, or to make a figure walk. Some are purely capricious, and others contain complete scenes in caricatures, for example. Yeah? Not all automatons, however, are mimetic. Some offer only visual fascinations, such as spinning roundels set with gems to make flashing patterns of color and light. And what you see here is an automaton in the form of a ship by Hans Schlotheim, created 1585. Automatons like this music clock in the form of a ship were used as festive table decorations intended to amuse and entertain the diners. The effect was increased when they were designed to mechanically imitate real-life action and could produce a melody as well. Here with the music again. Gradually, the traditional centerpieces lost their original functions and developed into mechanically moving toys and gadgets. And finally, into automatons proper. A mechanism and a musical clockwork allowed this ship automaton to roll across the table while the tiny musicians on it could be heard and seen to play their instruments. The date 1585 in the inscription and the imperial double eagle on the flags and banners suggested the ship was intended to Rudolf II, the emperor of Austria at the time, who had court in Prague and had really a fascination for automatons. So there's like a whole collection in the Kunsthistorische of these incredibly weird, strange, beautiful, fantastic music-making machines. Of course, there's much more than that. I would say that there's already at least written evidence of Heron of Alexandria creating automatons that created music in Alexandria, or most famously also the water organ. You see a reconstruction of it here on the left side. And the first known automatic playing orchestrion, which is the one in the middle here, was the panharmonicon, invented in 1805 by Johann Nepomuk Melzl, meant to play Beethoven's Wellington's Victory self-playing. And of course, the famous self-playing piano. Yeah? Though all of these machines did not compose music, they form part of a larger trajectory of music technology, which ultimately AI and music is part of. And now we're going to do like a huge jump forward. There would be much more to say about this sort of machines, but the limited time allows us only to do a couple. And we're going to go to Alan Turing. You should all know him. So we're going to increase the pace here a little bit. As you know, he's the father of modern computer science and a massive gravitational field in so many important areas of contemporary research, including artificial intelligence. In 1951, he recorded the first computer-generated music. Mind you, this is not yet generated by an AI, but represents an important step in this direction. There he is working on the ACE pilot model 1950, which he used a year later to compose the music. The machine, which was used to generate melodies, fills much of a lab's ground floor and was built by Alan Turing himself. Several melodies were created, of course, including God Save the King and Baba Black Sheep. While Turing programmed the first musical notes into a computer, he had little interest in stringing them together into tunes, so the work was carried out by a school teacher named Christopher Strysheep. By the way, the term artificial intelligence was first adopted in 1956. This is around the same time, during the Dartmouth conference in the USA. But AI technologies and applications has become significantly more popular and capable nowadays, thanks to increased data volumes, advanced algorithms, and improvements in computing power and storage. In 1957, composer Leonard Hiller and mathematician Leonard Isakson from the University of Illinois at Urbana-Champaign programmed the ELIAC, the Illinois Automated Computer, the first computer built and owned entirely by a US university. To generate compositional material and create the musical work, ELIAC suite for string quartet. Not far behind, of course, it was still the Cold War era, so the Soviets were not far behind. And they created their Ural-1 computer in 1960, which the Russian researcher R.T.H. Zaripov published the first paper worldwide on algorithmic music that was designed around this computer. And he used it for the composition of the theoretical work he did in the paper. The paper was called An Algorithmic Description of a Process of Musical Composition. So what you see here is the 17-year-old American inventor Ray Kurzweil. You might have heard his name before. In 1965, he premiered a piano piece created by a computer that was capable of pattern recognition in various musical compositions. The computer was then able to analyze and use these patterns to create different novel melodies. It was debuted on Steve Allen's I've Got a Secret show, which is what you see right here now, and stumped the host until film star Henry Morgan guessed Ray's secret. Kurzweil is to this day a well-known manufacturer of musical instruments, but more importantly, an excellent author on AI. So I can also highly recommend his book, The Age of Spiritual Machines. the American composer and scientist David Koch from the University of California, Santa Cruz, developed a system called Experiments in Musical Intelligence, EMI. And you just heard a composition that was done by that system. The EMI was based on generative models to analyze existing music and create new pieces based on them. EMI was a major breakthrough. Through analyzing different music works, systems could generate unique structured musical compositions within the framework of specific music genre. EMI has created more than 1,000 different works based on the works of more than 30 composers who represent different musical styles. There are many more examples to illustrate the development from machines that replicate music, such as a panharmonicum and the record player for that matter, towards machines that compose music or inspire the author with its reflective and generative qualities. Examples like Sonos CLS or David Bowie's collaboration with Ty Roberts, which resulted in the Verbizer of flow machines, Amper Music, and more. So there's like a whole plethora of machines now that do that. We're going to have now a little peek under the hood. So basically what is happening in terms of neural networks when you're trying to compose music using a neural network or create music, generate music. So music generation can be divided in a series of sub-problems. So number one would be the melody, yeah, which can be divided again into the melody being played by a single instrument, and the single instrument can be either monophonic or polyphonic. For those who don't know, monophonic means it only can play one note at a time, and polyphonic means it can play several notes simultaneously. Then, of course, there's multiple instruments involved in a melody. Then the second problem would be accompaniment. The third would be AI duet. So we're looking into a specific algorithm that is basically generated to understand how, if you play, let's say, a melody or a bass line, how it would automatically, for example, create a drum track. Yeah, and that's why it's called AI duet. And the fourth one would be the audio style transfer. So you remember how we did this with images, and I explained a lot about style transfer in my introduction lecture on AI and architecture, where it pertains to a target image and a style image, and you can actually translate the style from the style image into the target. In a similar vein, you can use that or apply that same concept to creating music. This also, by the way, is not only about the music, you can do the same also with lyrics. So important factors in defining the Python code include the input representation, which is a representation that is learning representations of input data, typically by transforming it or extracting features from it by some means. That makes it easier to perform a task like classification or prediction. There are various ways of learning different representations. Then on the right side, you see the model architecture. And the model architecture is a set of rules and methods that describe the functionality, organization, and implementation of the model's systems. Some definitions of architecture define it as describing the capabilities and programming the model, but not a particular implementation. And when I talk in this case about architecture, it's really talking about the computational model, of the architecture of the computational model. And then on the lower left, the data set. Yeah? The data sets, or a data set, is a collection of data. In the case of tabular data, a data set corresponds to one or more database tables, where every column of a table represents a particular variable, and each row corresponds to a given record of data set in question, right? So what we're specifically using in music generation, or the neural network we're using in music generation, is called an RNN, a recurring neural network. I mentioned this already before, that there's numerous neural networks out there. We're having a look into a couple of them in our class, like the style transfer neural networks, style transfer neural networks, but also a variety of others. But let's have a closer look how this actually works. how the model architecture of a recurrent neural network works. I don't know how many of you are familiar with electronic music and how to create music electronically. Those of you who have anything to do with music might know about MIDI. MIDI is an acronym for Musical Instrument Digital Interface. It's a technical standard that describes a communications protocol, digital interface, and electrical connector that connects a wide variety of electronic music instruments with computers and related audio devices for playing, editing, and recording music. The specification originates in a paper published by Dave Smith and Chet Wood, then of Sequential Circuits, at the October 1981 Audio Engineering Society conference in New York. And basically set the standard. So from 1981 till today, the MIDI standard was not changed. It really works really well. So that's one part of the architecture. The second part of the architecture is the so-called piano roll. Yeah, this is specifically for the application that we're going to look at here as an example. The piano roll is a music storage medium used to operate a player piano. You might all be familiar with the image of the punch of the roll of paper with punches inside that basically controls a piano. So that's sort of like the metaphor here, but you will see also that the way how you operate and interact with the software at the end very much resembles the quality of the piano roll. And by the way, I think that it's not a coincidence that the piano roll piano is so prominently featured in Westworld's, including in its title credits. I think this is absolutely clear that there's a correlation here between the understanding of what a host is, what an AI is, and so on. And it's very origin, this very primitive mechanical device that you can actually program to create specific output, maybe representing the unavoidability of fate within those robots that have a specific task to do and their memory being hampered with continuously. Again, but let's go back to the RNN. In the middle of the RNN is the SEQ to SEQ. The SEQ to SEQ is a general purpose encoder, decoder framework for TensorFlow that can be used for machine translation, text summarization, conversation modeling, image capturing, and more. So that is in the center of the RNN. And then when it gets to the output, it rolls back into the piano roll, and then the piano roll creates MIDI data, and that MIDI data can be played out by a musical instrument. You have to understand that there's a variety of different music formats, and they all have different levels of information and also in a different way. So if we go here from left to right, we have the raw, which is raw audio. This is basically a recording format and playback format, and the highest possible quality in terms of musical recording. There is no compression going on here, so the files are really large. And then it goes into MP3, which is also, again, an audio recording format that is compressed, thus losing a little bit of the fidelity within the sound. And those are like the ones that are a little bit closer to sound in a natural form. Then we have MIDI, which basically is discussed before. It can go, it actually is a system to digitally communicate between musical instruments, and they are exchanging data in order to produce music. ABC, a similar system. And then we go into sheet music, which is the data compression method to annotate music in an abstract way, which is the fullest semantic meaning of music when it's represented not by sound or by recording, but really just by writing it down. So let's have a look into an example of what I just explained. What you see here is Magenta Studio. So what just happened is that somebody just played a melody on a piano randomly, yeah, into the system. I have to add also that Magenta Studio is a collection of music plugins, which are using machine learning for a variety of tasks, and it can be implemented into Ableton Live. Now, what it's doing is you play the melody, and then you calculate it. Sorry again here. melody is played, then you go on the left side to the drumify, which is supposed to create a drum pattern automatically through machine learning. Okay, so this is an interesting problem. Let's go to somewhere else where it's a little bit more advanced than that. So there's this project called Jukebox, a really interesting AI project. So Jukebox is a neural net that generates music, including rudimentary singing as raw audio in a variety of genres and artist styles. So the model weights and code are publicly available, along with a tool to explore the generated samples. And Jukebox is based on a data set with 1.2 million songs, represented with a 12-second sample each. And this database is used for the conditioning of the machine learning process. And it's based on reinforced learning in contrast to unsupervised learning, which we're going to discuss another time. I also have to say that because we're talking here about machine learning and learning, reinforced learning and so on, I recently learned that there are a couple of different philosophies in regards of defining learning. It seems that European AI research laboratories are far more conservative and cautious when they talk about learning, because they have the opinion that we don't know enough about learning to really describe a computational process as learning. So here we are. This is Jukebox. I hope it's going to play the sound from this one here now. So there's a whole paper here that you can read about how it operates and so on, but it's really interesting. There are thousands of examples here, like all of the ones that have been done before, but here's a couple of curated ones that the programmers picked out just to demonstrate what it's actually doing. So for example, let's take this one here about pop. So the idea was to create pop in the style of Katy Perry. So they used a Katy Perry, they used their whole database, yeah. And the machine learning process was supposed to replicate that. The interesting part here is that this song does not exist. So basically similar to those web pages with this person does not exist, where images are created, generated out of millions of other images. This here is the same, but basically doing that with sound. Now, you hear that the sound recording, it sounds like it was really a crappy recording somewhere in the 1960s or something in a bad studio. So there is a lot of noise here. There's a lot of digital artifacts going on here. But I have to say also that this is the process of learning in this case is still ongoing, and the longer those learning processes run, the more precise the results are going to become. This year has been running for about well, it seems like a year. I don't know exactly how long it ran because it was recorded 4 months ago, and it might have been running for a couple of months to learn. So the longer you run it, the more precise and more accurate those things get. Let's go back and have another look. Maybe let's see what else do they have here. I'm not entirely convinced about the heavy metal one. But not so much because the sound quality is bad, but rather because I don't think this qualifies as metal. Anyways, this is another issue on its own completely. So let's go back again to the PowerPoint lecture. So that was Jukebox. Yeah. And now the question is, how is AI being used in a conventional way in the music industry? Yeah. So there are a variety of different ways that they are not necessarily about creating music. The music industry executive Scott Cohen describes it like this, in a quote: "There are 20,000 new songs on Spotify every single day. AIs assist in the sorting and categorizing of these vast amounts of data. AIs deliver recommendations to listeners, and what is interesting is that out of that new possibility of sorting and making suggestions to listeners, AI has basically made genres obsolete, which is an interesting thought because you don't look anymore for specific genres. You rather are being recommended according to your listening habits. So it's not a very specific process of, or let me put it this way, it's a very specific process of understanding what you as a listener likes. However, I'm rather interested in how AI is used in an unconventional way in the music industry. Hear and see it now?
Yes, yes.
So what you see here is the track Running by the AI Moni. And Moni was created by the Iranian multidisciplinary artist and futurist Kosh, who's a fantastic musician too. Very interesting character, by the way. You should look him up. He's amazing, super interesting. There's a lot to be seen and amazing work. Anyways, so this is basically what we discussed before, an RNN that was trained to create music, including the vocals. Yeah, and he has been published on Ninja Tunes with a variety of different tracks. So before the track starts, I'm gonna give you the heads up on this one here. So this is a track by Holy Herndon. Yeah, she's an American composer, musician, and sound artist based in Berlin. And she studied actually composition at Stanford University and also did her PhD at Stanford University in the Center for Computer Research in Music and Acoustics. And pursuing, of course, an international career in music. And her music very often combines human singing voices, including her own, but the rest is completely computer-based. She has been an avid user of neural networks recently to do her work. So that was Holy Herndon. And of course, apart from the music being generated in the way that I explained, you can also, of course, see that there is a spillover into the visuals where neural networks are very visibly in play in the transition between the imagery and the way how it's generating these really estranged visuals of humans and how they're combined with each other and so on. I think this is really a wonderful example. Now, let's go into a little bit more extreme areas here. So this is a group called Databots, yeah? So Databots is the brainchild of C.J. Carr and Zach Zukovsky, a couple of musicians with a strong interest in algorithmically generated music, who also on the side write scientific papers about it. And for a couple of years, the duo has been working on developing a recurrent neural network that can produce original compositions after being trained on specific data sets. So you see that's a repeating motif here, the training on data sets, of course. And the data sets are all organized in specific musical genres. Yeah. Early experiments incorporated a variety of different genres, but before the duo discovered that metal and punk in particular seemed to be better suited to the erratic and often random nature of algorithms. Yeah. And a quote, we observed that electronic music and hip hop instrumentals did not seem to train as well as organic electroacoustic ensembles of musicians. End of quote. Carr and Zukovsky write in their most recent paper, and I quote, music genres like metal and punk seem to work better, perhaps because the strange artifacts of neural synthesis, like noise, chaos, grotesque mutations of the voice, are aesthetically pleasing in these styles. Furthermore, their fast tempos and creative use of loose performance techniques translate well to sample RNNs, rhythmic distortions, end of quote. The end result has been dubbed Databots, and the neural network has produced 10 albums to date, inspired by artists including Dillinger, Escape Plan, Meshuggah, NoFX. As well as creating the music for each album, algorithms are created to design the album art and generate the song titles. I have also to add to this that they coined a term for the style of music that you're going to hear right now, which is called math metal. Okay, if this is not the most brutal metal of all times, I don't know what is. So another one, let me stop here again. You might remember Mario Klingemann from our last lecture last week, and LA-based band Yacht used thousands of photos and 4K video, and they gave that to Mario Klingemann to create the video for the music you're gonna hear now. It is based on a style GAN. We discussed this already last week. And at the same time, the music is created through using the RNNs. I would actually say that this is more than just a simple morphing process. It is the calculation artifacts that form the most original part of this video, the uncanny, the unexpected, the familiarization of the object. You might remember from last week my discussion on speculative realism and aspects of ruination, which are of course really visibly in all the work we've been seeing today and hearing today. Because of course, this is not only relating to the visual, but also to the audio. It can also create the same artifacts. And of course, there's like an inherent provocation in that. I would also argue that some of Schopenhauer's thoughts on die Welt als Wille und Vorstellung, the world is will and representation, or even just the provocation of dismissing these thoughts, is ultimately what would be an interesting discussion between the realism aspects and aspects of idealism, which is present, I think, in the entire work we've seen today, and would actually entail a longer conversation, which we might hopefully have another time around. So really strange indeed. You might remember the example that I showed you of the RNN that was able to output MIDI data that was using the piano roll system. So the work of Yacht seems to be based on a similar system, as the resulting music is, I mean, if you compare, for example, the sound quality of the Katy Perry or the math metal example, which was really raw and full of artifacts and really bad in certain terms of sound itself. This one is super sharp and clean and studio quality. So what's happening here is that instead of sampling their music to create new music, they're basically just using the system to create MIDI data, and the MIDI data is then played out to instruments that can be recorded cleanly. So one is really creating MIDI data for the studio environment, and the other system is basically like using imagery, as we have been using, for example, in our style transfer techniques to generate the information. An artist in a similar vein, Chandra. So Arce, as she is also known, you saw in the video before that there's like there's a correlation between the visual style of the video and the music. It's obviously based on Jamaican raga influences. Would be interesting to explore it a little bit more. She's a Venezuelan artist. I think it's quite an amazing work. And here we are again with Kosh. This is one of the most new releases from Kosh, where again also the workings of neural networks is really visible in the visuals as well as in the music.
Do I love art more than love?
Really overlap between the
two. Do I love art more than love? 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 Do I love art more than law?
I like to use words like cheers. I like to use words like rapper. I like to use words about law. I like to use words about law. I like to hang out with Matt. I like to kick back with Joe. My mind turns straight to art.
Do I love art more than law? Do I love art more than law? Do I love art more than law?
So, and I would like to end the lecture with a quote from Databots, and I quote, "Becoming mainstream has been important for subcultures that were underrepresented and needed a voice. Teenagers, African Americans, etc. Whereas tech culture already dominates the world. It's swallowing the music industry as a whole. What does it have to gain by making mainstream music?" I think that's a really interesting thought there, that music suddenly is not there anymore for the gain of notoriety or fame, but rather for the sake of creating good music, I guess. All right, thank you very much. That's it for today in terms of the lecture. If you have any questions, thoughts, comments, please let me know.